All right, I'm going to work through the 7.3 chapter review exercises. You can use these to help you study. You'll see the exercises here on the right if you want to reference them as I scroll through them. So I'm going to be scrolling past this. Again, and just a quick review, if you look in your textbook, you'll see these properties in there, this being the product property, quotient property, this is the power property. I'm going to be using those throughout the video. So please review these if you need to. Let's look at 38. We want to write the expression as a single logarithm and identify the property used. So it starts off with log of 8 plus log of 3. Now, just what you remember for the product property. If you scroll up again, it says if you do log of A times B, that's the same thing as log of A plus log of B. I'm going to briefly explain why. All right, let's say 2 to the power of 4, and you multiply it by 2 to the power of 7. Don't you get 2 to the 11th? Now, again, these are exponents and these are logs, but that's basically why it works. Multiplication is repeated addition. So it's kind of the same rule with exponents. Multiplication connects to addition. So just like here, I'm doing 2 to the 4 plus 7. That's a way you can memorize these properties. But here's what it means. It means this is log of 8 times 3, or log of 24. I don't need to put the parentheses. I just put log of 24. I just like to think of it that way. So, and then this is called the product property, is what I'm applying there. Let's look at 39. Okay, for number 39, I have log base 2 of 5 minus log base 2 of 3. Just like where I did the other one, I'm going to do something similar. All right, let's say we have 2 to the 7th power over 2 to the 4th power. And this is just a way to think about it. Well, isn't that 2 to the 3rd power? Well, how do we do that? We did 2 to the 7 minus 4. Notice how when you're dividing exponents with the same base, you can think of it as subtracting the powers. Well, that's what's happening here. So this is log base 2 of, it's separated subtraction, but really it's division. Now I would leave it as 5 over 3. Yeah, you could write 1.6 repeating. So you could do log base 2 of 1.6 repeating. If you just do 1.6, it's technically not correct. You got to put the repeating. But it's better to do it as just an improper fraction and leave it alone, because it's an exact answer. It's written just fine like that. If you need like a real life connection to it, that's what decimals are great for. We connect more with decimals than fractions, like we're able to estimate it more. But this is it, and again, this is called the quotient property. All I'm doing is applying that property. Let's look at number 40. We have 4 times log of 3, log base 3 of x plus log base 3 of 7. Now here I'm going to use the power property right here to move this 4 up back here. So this is log base 3 of x to the 4th plus log base 3 of 7. And then I'm going to go, oh wait, separated addition is just multiplication. So this is log base 3 of x to the 4th times 7, or log base 3 of 7x to the 4th, if I want to write it all as one thing. So I use the power property in the first step, then I use the product property in that second step. All right, number 41. To simplify this one, it has just log of x minus log of y. Again, separated subtraction is just combined addition, so this is log of x over y. It is log base 10 for reference, in case you're wondering why there's not a base, but we talked about that. That's it, and that I'm using the quotient property. Number 42, I have log base 5 minus 2 log base x. Again, my goal is to write this as a single logarithm. I know I can apply the quotient properties, like, oh, I see separated subtraction, but before I do that, here's the thing. Again, I'm going to use the power property. This is log. You can either put the 2 out in front of the log, or it can go up on top of the x. This is log of x squared. So I have log of 5 minus log of x squared. That's the same thing. Separated subtraction is the same thing as combined division, is how I like to say that. And again, that is there. I'm applying the quotient property there. Okay, last one of this section where we have to write as a single logarithm, number 43. 3 log base 4 of x plus 2 log base 4 of x. The bases are the same, so that's great, but I want to take these numbers right here, apply the power property, and send those up here. I want to write them as a single logarithm, so this is log base 4 of x to the third power, the power of 3, plus log base 4 of x to the power of 2. Separated addition is combined multiplication, so this is log of, I'm going to put parentheses here, x to the third times x to the second. Now that's correct, but you can go a little simpler. These can actually be combined. This is log of x to the, well, that's the fifth power. Boom. And I don't need the parentheses. I can just do log of x to the fifth. But if you put the parentheses, it's not wrong. I'm just so used to writing it because I do it in my TI-84 calculator. The TI-84 would put parentheses. All right, 44, different set of instructions, but we're still just rewriting logs. We're using properties. We want to expand this, and then we're going to use properties. So we're kind of doing the opposite of what we did before. So this is just good practice right here. Log base 4 of x squared y to the third. Now, you could do this a lot of ways, but now we have combined multiplication. So let me separate it into separated addition. So this is log x to the fourth, log of y, log base 4 of y to the third. Anytime you see these, by the way, these kind of questions are usually going to be multiple choice. It's going to be, hey, which one of the following is equivalent to this? Now, this is true. This is, I did expand it, but I could expand it a little more. I can take the 2, drop it down here, take this 3, drop it in front here. And again, that's the power property. So first, I use the product property. Then here I'm using the power property. So this one's 2 log base 4 of x plus 3 log base 4 of y. That is like as expanded as you can get here. Okay, number 45. We're unsimplifying it in a way. So I have log, and this is log base 10 because there is no base visible, of 4 s to the fourth t. Now notice how there's like 3 things connected by multiplication. So this is log of 4 plus log of s to the fourth plus log of t. Again, I'm using here in that step, I'm applying the product property. Now I'm going to apply the power property to only this part right here because it's only one with the power. So this is log base 4 plus, I'm going to take that 4 and then drop it in front of the log. So I got log 4 times log of s plus, and then rewrite this log of t. That's as expanded as you can get. Okay, number 46. We start off with log base 3 of 2 over x. And remember how we had separated subtraction is combined division? Well, it's just the opposite here. I'm going to apply the quotient property. And combined division is separated subtraction. So I'm doing it backwards. Log base 3 of 2 minus log base 3 of x. That's as expanded as you can get. You can't expand it any further. Let's look at 47. I have log of, now this is x plus 3. That's like that whole thing is a base, and then squared. Okay, so I got to be careful here. So this is log of x plus 3 squared. I can do this. I know I can do this. I can take this 2 and like drop like that. So I can do 2 times log of x plus 3. Well, that's it. That's all I can do. Here's when you want to be careful. You might think, oh, well, addition and multiplication like link up together, but careful, don't do that. You want to be careful about trying to do that because, yes, combined multiplication is like separates into separate addition, but it doesn't work the other way around. log of AB is equal to log of A plus log of B. But log of A plus B is not equal to log of A times log of B. So this is not a property. So don't go trying to go any further. This is really about as far as you can go. You can check, again, check these answers on the back of the book. If you see me make any mistakes, please call me out. But the chapter review answers, they're not just the odd ones. All the answers are on the back of the book usually. All right, number 48. We have log base 3. I'm sorry, log base 2 of 2y minus 4 all to the third. Again, you might be tempted to do the quotient property, but no. Combined division separates and subtraction. This one is just all you can do. The only way you can rewrite this is by taking the 3, put it in front of your log base 2 of, and then it's 2y minus 4, and then that's as far as you can expand that thing. Let's look next at number 49. This is log, and then you see the exponent is z to the second. I like to write my z's with a line through it, or z if you're Canadian. All right, combined division is also the same thing as separated subtraction. So this is log of z squared minus log of 5. This is correct, but you could do, you could go further if you want. Again, these kind of questions are usually multiple choice when you encounter them in any test. So 2 log of z minus log of 5. That is the expanded form of that logarithm. Okay, that's all of these. Now, for numbers 50 and 51, I'm going to revisit something I showed you in your calculator before. Log base 2 of 7. Here's what the change of base formula is. If you take log base, and I'm going to use an a right here, and I'm going to use a b right here. That's the same thing as log of b over log of a, where log is like, this is like log base 10, this is log base 10 of a. And it doesn't matter if you do it with log or ln, it doesn't matter what button you calculate, but I'm going to show it to you in a second. So here's what it is. The change of base formula, this one would be log of 7 over log of 2. Now I'm going to prove it to you by, again, demonstrating something that we showed in our calculator before. So get your calculators out, and what I want you to do is type both of these in to your calculator. Now, when I say type both of these in, here's what I mean. Type the original expression by doing this. If you turn your calculator on, and you just go to your home screen, I'm going to just clear everything out of here. Math, scroll up. See that log base option? Hit enter, and it allows you to actually type in log base 2 of 7. See how it gives me 2.8, roughly. Now watch this. Now I'm going to do the change of base formula, which is a easy way to remember is like, wait, which one goes on top, which one goes on bottom? Well, you notice how 2 is lower down? When I say 2 is lower down, I mean, look, 2 is like low. It's the bottom, it's the base is the bottom, so it actually goes in the denominator. It's just nice that it works out that way. It's a nice little mnemonic for remembering it. Log base 2, I'm going to put that right here. Watch when I hit enter, boom, that's the change of base formula. Now that we showed that it does work, for the last one, 51, I don't really have to check it in my calculator again. Because I know that it does work, I can just write for 51. You see that it is log base 3 of 10. Now, notice that's not log base 10 of 3. That's log base 3 of 10. So, log base 3 of 10 is just you take the log of this thing over the log of the bottom thing. Now, that's all well and good. This actually, in a way, could be simplified further. This is log base 10 of 10. So really, log base 10 of 10, you could actually simplify it to 1. So, and then log of 3 is just some weird decimal. You could, if you want to, do this. 1 over log base 3. Those will come out to the same thing. And I'll just confirm that in my calculator. So I'm going to do 1 over log of 3. So I'm going to do log of 3. And I'm going to just confirm that that's the same thing as the original thing. I'm going to go to math. Log base 3 of 10. And bada boom. They are the same thing. All right, that's it for section 4.